Yes. And then I'm combining it with hydroxide. So that's OH, and what oxidation does that have? -1. So how will I write that compound? Plus, what's my other product? Hydrogen. So we just write that bad boy in. Alright? Now, we can leave H2O as H2O, or we might want to rewrite it as what? HOH. So I'm going to rewrite it as HOH to make it a little easier to see. So I've got 2 hydrogens, and I only have 1 hydrogen here. So I'm going to multiply that one by 2. That's going to give me 2 OHs. So I'm going to multiply OH by 2 over here. That's going to give me 2 sodiums. So I'm going to multiply sodium by 2 over there. Alright, let's make sure that this reaction can take place. I'm looking for sodium to be higher than the hydrogen of water, which means we're looking at that shortest line. Miss White? Yes. Uh-huh. Sure. Monet, Ochelet, Miss Davis, can see in the council center. Alright, so here's sodium. Here is the line where the metal can replace hydrogen in water. So sodium just barely makes it, but it made it above that line, which means the reaction can take place. Alright, let's say we have nickel plus H2O as gas.
You said the gas?
Mm-hmm. Alright, and if you want to check the activity series first, we could do that, and then you would know whether or not you even had to do the problem. So we're looking at nickel. Nickel is Ni, right? So if we're looking at the activity series, we're replacing hydrogen from a gas this time, which means we're looking at this line right here. Is nickel above this line? No. So if nickel is below the line, then that means that the reaction cannot take place. And so if you check your activity series first, then you can just write in no reaction. Let's say you had completed the reaction and then checked the activity series. That's fine. So if you end up with the whole problem written out and then you realize the reaction can't take place, all you do to signify that is over here on the products, you're just going to put an X across them. And that's going to show me those that's what the products would be, but those products won't form. Okay? So you can do it either way. Alright, let's look at C. So C, we're replacing the active metal from an acid. So we've got our metal still, plus HX. This is our acid. Remember, acids always start with H. So X can be ever changing depending on what acid we're combining it with. Then we're going to form a metal plus that X, whatever's attached to hydrogen, plus H2. On our activity series now, we're looking all the way down to that third line. So the metal has to be above that third line in order for the reaction to take place. So let's say we were doing strontium plus sulfuric acid. All right. We can check the activity series first if we want. Strontium is SR. Is SR above that third line? Yeah, it's actually way up there, right? So it's pretty high on the activity series list. So we're good then to proceed. All right, I'm going to go ahead and get strontium's oxidation number. What is it? Number 38. 2. All right. Now, I do need to figure out what sulfuric acid is. If it's an acid, it automatically contains who? H. And H has what charge? Positive 1. All right. Sulfuric, I see, means that this was which polyatomic ion? Sulfate. So what is sulfate? SO who?
SO2.
Nope. SO4, negative 2. I know that the reference table, the way they write the things all on top of each other is kind of confusing sometimes. So make sure that top number with the charge right next to it, that's your oxidation value. So SO4, negative 2. All right, so let's write these out. Is strontium diatomic? No. How would I write sulfuric acid? Yep. All right, now I'm ready to form M and X. So M is strontium, X is sulfate. All right, everybody see how you break that apart? Because it's H plus X. So X is whatever is attached to your hydrogen. All right, and this time it is sulfate. And then our metal is strontium. So we're going to put strontium, which is a +2, with sulfate, which is a -2. So how would we write that? Good. SrSO4. And my other product will be H2. Alright, and then it looks like this one is already balanced. So 2 and 2, 1 and 1, 1 and 1. So this one's already good. Alright, and the last type of single replacement is our halide replacement. So you'll notice the equation changed a little bit. I've got D plus BC gives me BD plus C. So halides are negative. Okay, so that means that D here is a non-metal. My single element this time is going to be a halogen. So if your single element is fluorine, chlorine, bromine, or iodine, then that's your signal that it's automatically a D type of single replacement, okay? Which means B is still positive and C is my other negative. So D and C are switching places because you have to switch a negative for a negative or a positive for a positive, okay? So we're looking at our halide chart, and again, it's pretty easy to remember. because it's in the same order they are on the periodic table. So fluorine is at the top, iodine is at the bottom. So if you're looking at your periodic table, they're easy to make sure you know whether it reacts or not. So let's say we have chlorine plus sodium iodide. So first of all, can chlorine replace iodine? Yep, it can't. So let's find all our pieces. Chlorine is what oxidation number? -1. Sodium is +1, and iodine is -1. Good. All right, now we can write our equations. Is chlorine diatomic? Yes. How do I write the compound sodium iodide? Na. Alright, remember we only use the rules of diatomic if they're all by themselves. Okay? When they have a compound, you use the rules of oxidation. Alright, so now we're ready to form our products. Let me label these guys. This is D, this is B, and this is C. So, first thing I'm going to form is B and D. You got to make sure you write them in the right order. So, B is Na, and D is Cl -1. So, what compound will that make? Good. Plus C. C is iodine. I'm writing it by itself, so the only question I ask is it diatomic? Yes, it is. So it would be I2. Alright, I need to balance this one out. I got 2 chlorines, so I'm going to multiply that one by 2. That's going to give me 2 sodiums. I'm going to multiply that one by 2. That's going to give me 2 iodines. And I already have 2 iodines. All right, let's do one more. Let's say we have bromine plus lithium fluoride. Can bromine replace fluorine?
You said what?
Can bromine replace fluorine?
No.
No. Nothing can replace fluorine, right? So this would be a no reaction. All right, so those are the 4 different types of single replacements. All right, similar in how they exchange, but different in the way they form their products. So important to make sure that you follow the guidelines inside of your reference table. Let's look at double replacement. Now, there's not as much to do with double replacements, but double replacements, you have to use what we call the solubility rules. And if you look on your reference table, right above the guidelines, you'll see the solubility rules listed. All right, these are the rules that tell us whether something can mix with something else. If both of your pieces in your reactants are soluble,